Say when. Okay. Good afternoon, everybody, and welcome to DNSOP Part 2 for IETF 119. You started your week with us, and now you're ending your week with us. Thank you. We appreciate it. Okay. Eh. Yeah, the clicker hates me too. All of the usual suspects. If you were in our session Monday or any other DNSOP session for going on a while now, you know who we are. And Tim is online. We'll be here in spirit, and all of the usual details. You've also all seen the note well. It means the same thing it always did. Basically, by participating in this meeting, you are consenting for whatever you say to be part of the IETF process. Meeting tips for in-person, you need to sign into the session using MeetEcho. It's helpful for the chairs if you use MeetEcho to join the queue, even if you're in the room. That makes it much easier for us to manage a single queue. And please keep audio and video off if not using the on-site version. It just contends for bandwidth, and audio video, the AV crew in the room is making sure stuff works. For remote folks, we're glad you could join us, but please make sure your audio and video are off unless you're chairing or presenting, and use of a headset is strongly recommended. And the IETF Code of Conduct. Again, everybody has seen it by now. We're all grown-ups. We know what this means. And just a reminder that your chairs and your AD take this very seriously. We work as individuals. We should be being nice to each other. If there is a line between vigorous discussion and violating the code of conduct, and if anybody who feels that that line has been crossed should feel free to come to the chairs or the ombuds team. So, agenda for session 2. I think we did everything except for consideration and time permitting. We got to some stuff Monday. The updates. Yeah, we already did the updates Monday. Yep. So for today, report on the DNS delegations BOF, just because a bunch of people in the room are interested, and we have this session after the BOF. So Tal, I guess you have a few minutes, and then if people have other observations they want to share, we have a few minutes for that. We have 3 West Hardaker drafts for the price of 1. And this is really one work item, or one proposed work item, having to do with rearranging some of the details of crypto algorithm registry for DNSSEC. We have, I think this is a new draft from Willem on ranking the authoritativeness of sources of information, sources of data in the DNS. And if we have time, the automated delegation sync from child to parent that Johan has been working on. I believe a bunch of people were involved with some efforts along these lines in the hackathon. And Peter has some work on measurement of CDS and CDNS key inconsistencies. So that is it for the chairs. And Dale, if you have anything on the delegation BOF?
Hi, so I prepared no slides on this because it was just basically going to be a summary of what my impression of what occurred at the delegations BOF. As many of you know, I am one of the co-authors on the original proposed deleg draft with Tim April, Ralph Weber, and Petr Spacek. The purpose of the BOF, though, was to kind of go back to square one. Like we put a proposal out here about, oh, well, we want to update, our delegation mechanism in the DNS, and here's the way we think we should do it. And a lot of people got really excited about that and said, yes, we should update the delegation mechanism in the DNS, but is this really the best way to do it? And so for those of you who have not been following it, if this is a topic that interests you, the place where this is now being discussed, because it would be a little overwhelming for DNSOP for it to happen, is a new IETF mailing list that is named DD, that's Delta Delta, at IETF.org. Please subscribe to that list. We are, the result of the BOF, basically, I would say, was it went very well in that for being a potentially contentious area, all the engineering factions that are lining up on different sides of how we might do this, we're all able to have a very progressive discussion as far as this does seem to be an interesting problem space to work on. We're really not sure of what the solution should be. So let's start with the purpose of the BOF was to consider the possibility of forming a working group. So it's, again, not to overwhelm DNSOP about it. And so the direction that things seem to be moving in now is that we are trying to settle on the charter for what such a working group would look like. One that leaves open the possibility, of examining all of the different possible solutions. And that itself kind of stepped ahead of, first, we're going to identify exactly what problems we want to work on that we're developing solutions for. And so some wordsmithing is going on now for the charter that tries to leave open this kind of greenfield area of saying, well, once we identify specifically what problems we are in scope for this working group, then we can start evaluating what different solutions we might like. And Miria has already made her report for the IAB as to the success of the working group BOF, which I can summarize briefly, as it does seem like a lot of people are interested in working in this problem space, and so it's probably going to make sense to go ahead with a working group. Ultimately, it is a decision of the IAB as to whether we spin up another working group in the DNS area to work on this particular problem. And the one other thing then I can just say, this was not specifically about the BOF, but talking to a number of the advocates behind the deleg approach in particular, while we are still going to be developing that in parallel and working on documentation around that, it's our intent to still participate in the group. It's actually, we think, very valuable to identify the different possible solutions and why we might prefer this or might prefer one of the other ones that emerges from the group. So I don't really have anything else to update. I want to give you some back if your time permitting to let other people get it.
Sure. Yeah, but we're inviting, since we do have a few minutes, and this was of great interest to a lot of people, we were encouraging others, folks with observations, to speak. So that's,
Yep.
Go ahead, Wes.
Wes Herdeker, ISI, and obviously one of the chairs. I actually did think that it went really well, that we know that there's things to work on. There's already a fairly active discussion on the mailing list about the charter. Certainly, the sooner we wrap that up, the sooner we can hand it to the IESG and Morn and his crew can make a decision. One note about the IAB review. The IAB is an advisory role to the IESG, so they have no decision. Being on the IAB, right, I have no decision-making authority whatsoever. That's entirely up to the IESG. We just try and help look at architectural problems.
Right.
But other than that, I thought it went really well. Do review the current charter. It's in GitHub and makes change suggestions as appropriate, and then we'll get that over to the IESG and they'll make a decision.
Yeah, and just a really short comment. I think that all went really well.
Who are you?
Oh, Warren Kamari. I think the BOF went really well. If folk haven't seen it, it was recorded. It's definitely worth watching. We're expecting to be much more contentious, but we're all very pleasantly surprised at how well it went. And yeah, there seems to be good support, etc.
We are a kinder, gentler IETF now.
Exactly.
Jim Reid. Thanks to you, Wes, and also to Warren for all the hard work behind the scenes to actually get the BOF set up and come out with the draft charter. So well done for that. The question I have though is, when do you think we're going to get some kind of realization as when the charter has got to some kind of consensus point of view? I think it'd be helpful to have a rough idea of the timeline for that, and we realise we won't have a fixed date for it. But an idea of how things are likely to progress over the next few months would be very helpful. Thanks.
Yeah, I see you, Wes, and also Warren, if you want to sort of recap the process.
Yeah, I mean, as Paul and I have talked about it, and as the interim BOF, the interim chairs of the working group, because eventually it'll have new chairs. What we want to see is a discussion happen and sort of peter down, and it, if it looks like there's agreement on each of the items and they've come to conclusion, then it's ready for the ASG to review. Obviously, the faster that happens, the better off we will be. We'd like it not to go 3 months long, but my plan was to work with Warren, and I'm sure, Paul and I will work with Warren to determine, it looks like it's petered down to the point where it's ready for the IESG to review. So it really, to me, the timeline depends on the group, not on a hard deadline.
Yeah,
Go ahead,
Warren. Yeah, what he said. Basically, once the charter and stuff is settled down and people have agreed, then there's some crank turning that needs to happen. One thing that we all know is we are going to need some good and strong chairs on this. And so we're going to send out email asking for volunteers to chair. It's also not quite clear what area it will end up being. Originally, I was convinced it had to be in the ops area. But I think I've come to realize it doesn't have to be an ops. We just have to be very, very, very sure that there's strong overlap between the participants and strong coordination between the groups. Ideally sort of scheduled in a way that people can finish one working group and then move directly into the other.
Right. And Wes mentioned his name, but I just also wanted, since Jim had given a list of thank yous, I wanted to be clear that Paul Hoffman was also very important in, kind of getting the BOF off the ground. And the one little last opinion piece that I'll offer is that I know one of the concerns of, the advocates that kind of started off this whole, let's look at how DNS delegations are done, is we were really encouraged back at Prague about the number of people that were really interested in working in this problem space, and was optimistic that maybe after years about talking about doing something, we finally had the energy and the momentum to go ahead and do something. And so one of our concerns at the moment is losing kind of that momentum. But it also doesn't mean we want anything to be a juggernaut, right? Like there is a balance to be found, that we do good engineering, but that we keep up the energy and the momentum behind, what the problem that we're trying to solve here. So that's kind of where we are. We're definitely interested in still being very actively participating and moving this forward. And so far, it looks like a lot of the community is still too. So I'm still pretty optimistic about, something usable and useful coming out of this.
Super briefly, once the charter is handed off towards the ISG for their consideration, the mailing list remains open for that kind of discussion and hopefully to retain the momentum.
Yeah.
Oh, I'm still Paul Hoffman.
And I guess very last comment on that. I had generally been trying to name new mailing lists that were in support of a BOF, like BOF-something. In this particular case, it seemed relatively likely that this would eventually turn into a working group. So I didn't call it BOF-something. So we could hopefully keep DD possibly as the mailing list, whatever the new working group ends up being called, which assuming it gets chartered, which I think it will.
Right. And that last thing on timelines also was Eric Thank has also kind of pointed out that it should be, once it is handed over to the IESG, if a positive decision comes, or even a negative one, it should be about 4 weeks from that handoff to, like, let's please charter something.
And also from Warren, that sounds like a suggestion that discussion of the current draft should move to, any discussion that hasn't moved from DNSOP should move to DD? Just to keep it simple, just to have it unambiguous,
Yes,
because we
and
do
I-
get questions about
And
that.
I strongly recommend that everybody who's currently on the DNSOP working group list, and in this room, etc., join that as well. Because I really don't want it to be that this, whatever this is, gets developed in a vacuum and then people are surprised or upset. So, oh dear. Okay.
Yeah, well, in particular, DNSOP is very much, people that are very interested in the DNS, and we are trying to get a lot of cross-group participation from the different communities, because this is, somebody has characterized this, I think it might have been David Black, as the most significant change to the DNS since DNSSEC. So given that it would have such a broad impact, we definitely want participation from across the spectrum.
Thank you.
Fab. Wes? You didn't even have a clicker.
So this has been under discussion, I think, for years at this point, and I sat on it for too long, but RFC 8624 is a document that specifies the levels that we expect implementations to happen, like must, should, may, you must implement this algorithm, you must not implement this algorithm, and things like that. So Warren and I got together, and a lot at the prodding of Tim about getting it done this way. Our goal is to move everything to an IANA table, so we'll come to that in a minute. So this is not really a BIS. The document's actually labeled BIS, but it's really a replacement. It's actually almost entirely different. So today, basically what 8624 says is all the algorithm definitions are published in various documents and various RFCs, and they're added to, there's 2 IANA tables essentially. And then occasionally we publish an RFC with the recommendations that say, you can see the columns on the right, that say whether they're used for DNSSEC signing or DNSSEC validation, and whether you should implement them, should not implement them, must not, whatever. And the problem, there's multiple problems with this approach. One is when updating all of these recommendations is a heavy lift. The instant you open a document with a lot of recommendations, you end up in a rat hole of a discussion about each one, and it takes a really long time because you're basically discussing the entire slate again. And furthermore, the IANA table can actually get out of sync with respect to the recommendations in the first place. The IANA table can change, we can add entries, modify entries, and the recommendations table is no longer up to date with respect to what's actually in the IANA table. So the proposed new approach that we're advocating is move the recommendations into the IANA table, and this is basically what this document does. It does not in any way change the recommendation levels. It's literally a copy into place, and we can fight later over recommendation levels, but the existing one deliberately does not modify, which we actually struggled against ourselves because there are certain things we definitely wanted to change, and we're like, no. Let's get the table update, let's make the table updates. So the new goal is basically then we can use smaller RFC updates to make incremental changes, either to add and remove entries, but also to add and remove or change recommendations as well. And those can be discussed individually, and thus don't need to be bundled together as one big long thing. So after writing the document, we also wrote 2 short documents, one saying we must not use SHA-1 anymore. That's generally widely agreed, and another one that's actually called DNSOP must not GOST. And there's actually multiple GOSTs, so that was badly named. That's my fault, and it should really be the ECE GOST in particular. And the document actually, the current version of the document does specify exactly which GOST we're talking about. So this is what it basically does. It adds 3 columns to existing tables, and I might get to you in a second, Mike. We're gonna stop here in another slide or so. So there's 2 IANA tables. One is the domain security algorithm numbers, and one is the digest algorithm. And so we're adding 2 columns to the first one because that's the one that actually has algorithm numbers that apply to both signing and validation. And then the digest algorithm is for DS and CDS records. So we're just having 1 recommended column. One thing that I do want to bring up today, and this is I think the largest part of the discussion I expect to have, is right now adding rows to the IANA table is only an RFC required. I don't think we want any random RFC to say you must implement something, right? So something that goes through the ISE or something that's AD sponsored or any of the other paths, we don't want that. So we only really want some types of values to be standards action only. So there's sort of options going forward. We require all changes to be standards action, but that feels disingenuous with the purpose of the original table. Or we can make this dual level change. So ignore the text on the bottom because this is easier to read. So the point being is that a non-standards action, so like ISE or whatever, you can add an algorithm, but the only value you can put in the recommended column is may. This seems to be sort of what was designed originally. And then a standards action can do anything else. You can add something with any value, must, should, may, should not, whatever. And you can modify. So you can modify it upwards and you can modify it downwards. You can say, I'm going to take the may to a must. You can say, I'm going to take the must to a must not, whatever, things like that. So I will stop here. There's more slides to go in a minute, but to start off with, there's sort of two questions to the group. One, is the general approach a good idea? Doing, adding these columns to the IANA table. I will note, by the way, that this is actually done in TLS. This is not, the first time this is done. The TLS algorithms also have a similar column. And actually, we copied a lot of their text because that was far easier than writing it ourselves. So I think first up is Mike.
Mike Bishop. I definitely agree with the goals. Making it more granular and easy to flip these individually is a good thing. I guess my question is how often you expect this to happen, because there is an actual cost in dollars to every RFC we put out. And if this spawns 10 RFCs a year just to toggle bits, that would be very concerning. If it's going to happen, once every couple years, okay, that seems more acceptable, although that's kind of what we were doing before, I guess.
Yeah, that's a very good question. And so I have two-part answers to that. One is the documents that will be added will be small. So the cost, there's a cost per page that's, I think, thrown around all the time. I expect that making a single change will be small. But more importantly, I don't think that the IANA table and recommendations, it's something I've ever seen DNSOP discuss, on a yearly basis, right? These are long-term changes, as was discussed in SAG earlier today, related to it's taken 15 years to get SHA-1, even out of the recommended path for a bunch of algorithms. So, we're talking, it takes a really long time. Unless there's a massive cryptography break, it's unlikely we're going to make a change on a regular basis. But that's up to the group, right? Not me. So who's after Mike?
Should
I'm starting to get quite a
Right.
queue.
Yep.
Ray.
Right.
Yeah.
Right.
Yeah, Ray Bellis, ISC. Unfortunately, it's not on the agenda, but Russ Housley and Steve Crocker published what I thought was a very good short draft just before this meeting started on algorithm life cycles.
Yep.
And that seems like there's kind of a lot of overlap or synergy with this. I would hope that the other document does become adopted, and that where that affects this, that really needs to be considered.
Yeah, there's actually, and so we're going to get to a slide later. There's actually 3 documents that sort of overlap a little bit. And we did notice that one. I think that one's more advisory and informational than actually talking, on even a more general level. But yes, they should absolutely be aligned. I agree
but
completely.
the individual states that end up in that lifecycle document are ones that would then might appear in the IANA registry.
Yeah, we're using the must, should, may, standard IETF terminology that already exists in the existing document. If they want to propose changing, and they have a mapping, I think, in their document. Last I read it, I'm for sure they spent a month ago, so
Yeah.
not
Okay.
fresh in my head.
Right, thanks.
Okay, whoever's next. I can't
Paul
see the queue,
Hoffman?
so it's up to you
Yeah.
guys.
After Ray.
I have 2 concerns about this. I mean, I like the idea, but I have 2 concerns. One is it's not clear how much text you can put in the IANA registry giving context to the table. You might have to point back to the RFC. And which leads to my second concern, which is the RFC is about implementation guidance, not operational guidance. We hit this over and over. Should I be signing with this? Well, I look at this RFC and it says not, they don't understand. So I would not be in favor of this if it's just going to be the table at IANA, because you've lost too much context.
That is a fair point, and certainly there's always backward pointers for, this is where the value came from. I mean, IANA keeps track of that to some
Sure.
extent. I will say, by the way, I did go to IANA with, can you handle a standards action for some values and a
Mhm.
and a
Yeah.
a may? They said not a problem. they
That's
can do
not a
that.
problem. I'm concerned about someone looking at the table and misunderstanding the context of, oh, this means I cannot sign with this and such. So that could be that there's 3 paragraphs at the top, and some IANA registries have it. You don't cover that yet in the document.
That's fair.
If it's adopted, I hope that we do.
That's fair. And then we're going to talk in a little bit about the slide in the future of Schumann and Peter that want to add more information that we'll get back to in a minute.
Wes, do you manage your time in the queue? You have 10 minutes.
There's
Well,
plenty of time.
but
Eh?
we're gonna,
We're doing all 20, remember?
Yeah.
So we're
Yeah.
good.
20
Okay.
minutes for all the drafts.
No, that's fine, but
Yeah.
Plenty of time.
just to make sure.
Yeah, thank you.
Okay. No, I
Warren?
So yeah, I agree. We should have some explanation at the top of the registry so people understand what it's for. I originally got in the queue for Mike's question. I'm expecting like 1 a year or so, or possibly less. Although if there ends up being sort of quantum stuff, maybe there's a brief, spike of people doing stuff, but that's a problem for future.
Jim?
Jim Reid, I like this idea, Wes, and I think it's long overdue, so get on with it, please. The question I have, though, is about how is this IANA table going to be getting updated? Are we going to use some kind of expert review mechanism? How is IANA going to be told to make a change to this? Will that be done by working group consensus or what?
So that is so that's what this table describes, right? So it's
Yeah.
a standards action to do anything other than may, and new entries that need to be added by, the same process that goes through. I mean, so there's a good point for adding new rows currently requires an RFC. It's a small table, right? 255 values. So we don't do easy come, easy serve. So a RFC going through any mechanism to get a code point assignment can put a may in those columns. Anything else requires standards action, which means an RFC
Okay.
coming through a working group.
Thanks, Wes, because I remember when we were discussing things with the deprecation of the GOST algorithms, there were some existential questions about whether an informational RFC could update a standards track RFC.
And
Maybe we're
this,
going to talk
this
about this later.
fixes that problem.
Yeah,
That's-
okay.
That's one of the goals.
Yeah,
Yeah, thank
Thanks.
you. Okay.
Jadamas? You're in the queue?
Elliot, actually.
Okay. Very good.
Hey, good afternoon, everyone. Forgive me for not turning on my camera. You should actually appreciate that. Yeah, I think you should adopt this draft. I think it's fine from an ICE perspective. I think there's no problems here, though. There are like modest corner cases that I think will be uncontroversial, like if the draft was published as an independent submission and then later there's an update to the draft, or if there's another draft submitted as an independent submission that says, wait a minute, that was a bad idea, withdraw this. I hope that never happens, but you could imagine an independent submission saying, hey, wait a minute, must not for the draft that was already an independent submission. So I think that's one point I wanted to make. The second point I wanted to make was I really don't think this group should worry about page counts. In terms of RFCs, what this group and the SAG and CFRG and others should worry about is the security of the internet. Focus on that. Do a good job on that. Don't worry about the page counts.
All right, thanks, Elliot. Yeah, I was leaving the true corner cases until post-adoption. I'm sure we have a while to get this out the door, and we'll discuss those because I had the same question on corner cases. So, okay. Since there's nobody else in the queue, let me go on to the proposal from Peter and Schumann, and I'm going to have one of them stand up and talk about it so I don't have to. But they actually wanted to add another column that was about the current deployment level. So one of you has to do it. I'm not going to do it. You can either hear it or.
I'm not prepared. Okay. Well.
Neither is the microphone.
Yeah. So actually, it's not just Schumann and me. I think the author list of this draft is a little longer. I think Dwayne also is there and Victor. So we wrote a draft that we presented last year in San Francisco on multi-algorithm setups. And I'm not going to go into details about that, but that draft also suggests turning that algorithm list into an IANA registry, similarly as proposed by Wes. And we make an observation, which is that the current RFC, or the table proposed as he has it, makes recommendations targeted at implementations, not operational, just as like Paul just said. But as a signer, you need to know which algorithms are safe to pick if you have a multi-signer setup, or even not a multi-signer setup for that matter. And so for that, to that end, it's more useful for a signer to have some kind of descriptive list of algorithms that are usually supported by deployed resolvers, and then pick from those, as opposed to looking at a list and then people must implement something. And I don't know if that means that if I pick that, it'll be validated. So we're proposing to add a column to this table, which is not prescriptive regarding what you must or should implement or must not, and so on, but descriptive about the support status in validators in the field. And then, of course, the question is how do you determine that and all of that? Fine, I think that's a different discussion. But for example, for algorithm 8 and 13, it's probably not contentious that they are universally supported. And well, I guess 8, at least, if you don't do that, you don't really do IANA DNS with the root. Yeah, so if this prescriptive must and the descriptive does, people actually like offer it for validation. If that's not the same, then we should add this column, we think, and then we can, of course, come up with like rules, how to change the content of the column, like, you know, RFC publication required, all of that. And yeah, so there's the multi-signer use case. There's also the use case of the root KSK rollover, which I'm not going to really go into, but obviously you would also only choose algorithms for the root that are universally supported for validation. So we just wanted to point out this intersection of the drafts here and suggest that they could be somehow, you know, fruitful to each other.
Cool. Yep.
Yeah,
Dan
so-
Gilmore, please.
Yeah.
Hi there. Yeah, thanks for this suggestion. In the comments right now, Jeff is pointing out that how do we measure whether this is actually describing universal support? Even if we know that all the major implementations offer the support, presumably someone who's deploying one of those implementations could turn off, say, like, I don't want to expose my resolution to validation based on SHA-1, right? So, like, how would you measure this, and how would we ensure that there are timely updates, right? If there's one major validator who decides I'm not gonna accept this particular algorithm anymore, then this would need to change pretty fast, or else you're gonna have people continuing to roll out things that don't have universal support.
Yeah, so those are good questions which need to be discussed, I guess, if the working group thinks that's a good topic to work on. My take is that it wouldn't have to be so fast. I mean, even if you change the value in the column tomorrow, it'll take a while until a zone maintainer is actually updated. And if you require an RFC for that, for example, then it'll take some time, but it won't be very contentious if really large operators turn a certain algorithm off. So yeah, but those are good questions. I don't have the answers, obviously. We just think that the column could be useful, and then we should think if there is a way to reasonably and meaningfully fill the column with values.
Wes Hardiker, ISI. So the value of the column, and so I actually don't have a strong opinion on this one in particular. And again, for the room, right, we would merge whatever needs to be merged to get the document out in the form that the working group wants. But if there is the longer the delay in getting the column updated from, you know, the condition of the world decreases the value of the column, right? And so the use case you brought up to me earlier is when Fedora decided to deprecate whatever algorithm it was, the world got hit pretty hard because a lot of people were still using it. So, and are still using it. Thank you, Paul. Yeah. So, you know, if it takes 3 years to update that column, then the value inside the column becomes less trustable. So have you thought about how to deal with that?
Sure. I mean, we can try to find a way that it doesn't take 3 years. Maybe it's fine to have expert review. I don't know. Perhaps for downgrading only, not for upgrading. I don't know. The way that universal flag for algorithms is used in our draft is actually also for when validators turn it off, that they then treat that algorithm like specially in a multi-signer setup. That's a little detailed now. I think we should not go into those details, but that doesn't, like, it's nothing to do with the timing in that case. I don't know what to say here at this point. Maybe we should take it to the list. Okay.
Yeah, I mean, sort of related to that, the only way I could realistically see this working would be expert reviewer and sort of the group of experts make their best guess at stuff, which feels fairly hand wavy. Maybe that's a separate registry under this, or some other sort of information. But
All right. So with all of that, the real questions for the day are, we believe that at least these three documents are at least ready for consideration for working group adoption. They should all be considered independently, not as a group, right? So there's the first one updates the tables. And then the second one are sort of the examples that we think are pending, recommendations that started all of this in the first place. One is SHA-1 and the other one is the ECE GOST. And obviously one of the things that the working group needs to consider either before or after adoption for the first one is, do we merge in Peter and Schumann's comment, or various, I guess, Victor's too, or not? Paul, you get the last really quick sentence because I have 2 seconds.
Sorry, I thought that you were going to be giving 2 presentations. With what
Yeah,
you
you do
just said, I do not believe not SHA-1 is ready for working group adoption, and I absolutely believe that must not GOST is.
Great, thanks.
We do actually have a couple more minutes for your entire, did you have anything else?
Well, so I think you gave me 20 minutes for all of them. And,
Yeah.
and so the first document's the critical one. The second 2 didn't matter if we didn't pass the first one, right? So I guess we have a couple of minutes, say the chairs. So does anybody have other comments about about the adoption of any of these in any factor?
I'll take an extra couple seconds on why the must not SHA-1. There's no security explanation in there about why not SHA-1. It just says, oh, it's not as popular or whatever anymore. Whereas the GOST one has good. So I would like to see what your security explanation is in that before we say adoption, because there are different ways of handling security about SHA-1.
Yeah, that's fair. I will say that the document, the SHA-1 document actually existed pre the other one because there was general agreement in the working group that we should get rid of it. But you're right, a better explanation, please send text. That's your favorite line, so.
No, because I don't agree.
Okay. Please have your enemies send text.
Jim Reed, I would just say adopt all 3 documents and deal with Paul's concerns when the documents get discussed in the working group.
Yeah, that's a fair point, right? Adoption does not mean publication. They're very different timelines. Any other comments?
Going.
Okay, I think we're good.
Fab. Thank you. And next, Willem.
I'll have to do. Yes. So this document's purpose is primarily to re-evaluate and rethink section 5.4.1 ranking DNS data of RC 2181. So RC 2181 is RC that's about a lot of different topics. And otherwise, if it would be only about ranking DNS data, we could do a 2181 bis, I suppose. But since it's just a subsection of this RC, it has to be updated. And so this subsection is assuming or is doing some assumptions on how resolvers operate that may not be matching how resolvers currently operate anymore. And also a lot of things have happened that influence, I think, this list, which may yeah, um, stimulate re-evaluation. So what is this subsection saying? It says if resolvers encounter certain RR sets at some point in the DNS ecosystem, then they cache them and they have a certain trustworthiness value. And if they then encounter the same name type RR set elsewhere, that may, and it has a higher trustworthiness value, then it should be replaced in cache. And the other way is around as well. If something is cached with a high trustworthiness value and you encounter the same name type elsewhere with a lower trustworthiness value, then you should not replace it in the cache. Yeah. So one thing I would like to address, or my prime motivation to get involved with this, is to add some missing DNS data to this list, namely the built-in root server addresses and the root hints. But while extending the list, I thought, and I also knew a few research papers that reference this subsection of this RFC. I realized that it also would be valuable if the different ranks had a value they could refer to. Papers actually do refer to it by value, but the value differs per paper. They make up their own. Sometimes 1 is the first rank, sometimes 1 is the rank with the lowest trustworthiness. So I'm proposing this ranking value, which is borrowed from what trustworthiness is, how trustworthiness is indicated in credit rankings. But I'm not really attached to it. Anything else could do as well. I do like that A means authoritative data as well. So that's easy to remember. Yeah, also the subsection uses some terminology which is not conventional anymore, I guess. It has a very unique and broad definition of the word glue. It's interesting that the terminology RFC mentions this mention of definition of the word glue as uniquely for only this RFC. And at that time, in July 97, we didn't have DS and NSEC, and that's another reason to come up with a more precise definition. There is a precise definition in RFC 4033, which is this. So then, instead of data from primary zone file other than glue, it could become data from primary zone file authoritative within the zone. Or glue from a zone file or a zone transfer could be non-authoritative data from a zone file or a zone transfer. And speaking of DNSSEC, I think it would also be nice if DNSSEC data could get the AAA status. So that if you would encounter it with a lower status, it will not be overwritten, right? If you have a verifiable DNSSEC secure status encountered from wherever, because that's in the spirit of DNSSEC. It doesn't matter where it came from. If you can verify it, it's good. Yeah, so like I said, there already has been a little bit of discussion on the list. And so the primary goal is to start re-evaluation and rethinking of all this. Yeah, for example, there's 2 kinds of data in the DNS. There's the regular data, which resolvers fetch for you or look up for you or resolve for you. It can be, or it is authoritative data and can be DNSSEC signed. And there's also the infrastructure data, which is used only by resolvers. And it's also in the DNS. And the first time resolvers encounter this information, it's served non-authoritatively. It's not served by the name servers that are authoritative for those names. And only afterwards it can be upgraded if you assume it is in the same cache, and RFC 2181 does assume that. But there are other resolvers that have a separate cache for infrastructure only or non-authoritative infrastructure only, and they will first try the authoritative infrastructure R sets and fall back on the non-authoritative sets if that doesn't work out, because child NS sets are not always very reliable. Some resolvers never use the authoritative infrastructure sets. They basically just have two caches, one for infrastructure and one for the actual DNS data to be returned to the stub resolvers. So maybe I think it would be good if we mention that, all those dynamics in the new version of this DNS ranking as well, and ask ourselves the question, what does ranking mean if you have two caches, one for infrastructure, one for data? Does it still have a role? Does ranking still applies independent of the cache? So there's a draft of Fujiwara resolver update that describes this way of resolving. And I do know that there's at least one resolver which has this implemented as described in the draft. Yeah, then in 27 years, a lot of things happened. The zone digest, zone MD is a record you can add to a zone. It is DNSSEC signed. And zone MD itself is a hash of all the content in the zone, including all the glue and all the non-authoritative NS sets. So what would that mean in the context of trustworthiness of data? What would it mean if you sort of have it indirectly DNSSEC signed, the glue, if you do have a local root and you verify the zone MD, but then you encounter that same address authoritatively, but it's not signed. Which one is much more trustworthy? Right, and perhaps it's also good in the context of the DLEC set to look at this. So DLEC may be signed. That would be the first infrastructure set that's authoritative in the parent, which would be great. It would get DNSSEC grade protection of the delegation, AAA status, or if it's not DNSSEC signed, perhaps B status. Yeah, I have seen some more considerations already posted on the lists. For example, how does EDN's client subnet impact the ranking? Or what does it mean for stale data? The prime goal, as I said before, is DNS has changed a little bit in the last 27 years. And maybe it's time to re-evaluate the ranking of DNS data list and start talking about it on the DNSOP list and come to consensus. So what do you think?
Okay. See Ben in the queue. Go ahead.
Hi. So I think it's great to have this like very deep and thorough analysis. I think that it is time to reevaluate this like ranking of DNS trust thing. I think the right answer is to get rid of it. There is the linear ranking idea of like this is the most trustworthy and this is the least trustworthy, I think was never true and is now like very obviously just not a correct understanding of how DNS actually works. I think that the very detailed partitioning here of different kinds of records with different uses in different use cases, and also a range of acceptable behaviors that potentially prioritize them in different orders, I think that is like a correct understanding of the system, and that's the sort of informational RFC that we should be putting out.
Yeah, I think some resolvers actually perform replacing RR sets in the cache precisely following these RFCs. So it is actual in use with some resolvers, but perhaps it could be, or the ranks themselves could be reconsidered as well. Perhaps it could be smaller, or there could be a different kind of description of how something, replaces something else. Mark?
Yeah.
Let me just turn things on. ZoneMD really doesn't change glue. Glue is a copy of data from somewhere else. So it's potentially out of date, which is why it's lower ranked. As for getting rid of this, when we get everything DNS6 signed, yes. Until then, we do have to actually work out what's less stale. And glue gets stale, unfortunately. Well, that was about it. And you verified versus verifiable data. Data should be, if it's been verified, it's more trustworthy.
Okay.
If it's verifiable, it's unknown.
Yeah.
Okay.
Thanks. I agree.
So yeah, Warren's
Warren's next. Yeah.
as an individual. Yeah, I think clearly we should work on this. Like I've been looking at that RFC myself recently, and there's a lot of stuff that's just kind of weirdly underspecified. I think I might have misunderstood what Ben said, because I think clearly there needs to be like a reasonable ordering presented, because we've seen a bunch of things where bad stuff has happened where people have done this wrong. So yeah, let's just do this.
Yep.
Hi, this is Daniel Conn-Gilmore. I agree that we need to have this kind of discussion. I think what we'll find if we have this discussion in detail with a bunch of different implementers weighing in is that there actually is no consensus. And I think this is similar to what Ben was saying, but maybe I can say it in a slightly different way, which is that there may be contextual things that we simply cannot represent in the sort of linear ordering that you're describing in this draft. But that does not mean, I don't think that means that we should not try to write this stuff down. I think we should try to write this stuff down with an acknowledgement that we are not going to reach a consensus on this, and actually describe some of the consequences of some of the trade-offs that different implementers make. And that means having to get people to at least a consensus on describing the characteristics that their implementation takes into consideration. And I think that itself is a useful outcome for this working group. So I think this is good work. I'm not sure that the structure that it's in is what we'll end up with.
Okay.
Ralph Akama is sort of blowing in the same horn. I mean, thanks for adding the stuff of all the discussions we had over the week. And I think it is, in the end, there's also a local policy that always wins in DNS. But I think there are multiple ways to do stuff. And if we can have that kind of as an informational RFC that describes here are the multiple ways to do stuff, then I think this is good work. And I will have to work on that.
Thank you.
Jim gets the last word.
Oh, thank you. What Warren said earlier, I think this is good work and we should adopt it in the working group. I don't care if we don't get consensus or not. We have to write this stuff up.
Okay. Thank you.
Thank you.
Yeah. Okay. Cheers.
Thank you very much. We'll take it also to the mailing list and plan a working group call for adoption. The same for the West draft.
And now, Johan. I think, Johan, you're next.
So I'm Johan Stenstam from Sweden, and as many of you know, we are working, as in Peter Thomas and me, on parent-child synchronization stuff. And we have several different mechanisms for this, one being the generalized notifications, and another one being based on the DNS updates. When it comes to the differences between these two mechanisms, the generalized notifications have a major advantage because the notification is just triggering a subsequent look up of a CSync record or a CDS record, and then do things from this, and you have a DNS signature chain to base your ultimate trust on. In the DNS update case, you don't. So that means that in the DNS update case, you do have some sort of bootstrapping issue to deal with for how to gain the initial trust of the child key in the parent to be able to, well, actually do anything with the updates that you get from your child. It should be said that the use case here is typically smaller parts of the DNS namespace, possibly internal to organizations, parts of the namespace that for various reasons are not DNSX signed, but we're not talking about millions of delegations, but we're talking about few delegations, like a few or 100 or 1,000 or something inside a corporation or healthcare system, academia, whatever. But the question is, assuming all those limitations, and given that we don't have a DNSX chain to work from, how far can we actually get with some sort of bootstrapping mechanism here? Well, we can do it in all sorts of ways, and most of them are bad. So if we just publish the record, and as in the public key of the child, and it's not signed, and you cannot really trust it in any way, it's very easy to do, but it doesn't really gain you much security. And you can do this in several different ways, and you can play with it a bit, and it's still not secure. But if you then think about this, we actually have some prior art. And we do have RFC 8078, which describes how to gain initial trust in a CDS published by a child. So it's a signed zone, but there's no signed delegation. And this RFC describes how to do this by looking from multiple vantage points, for instance, looking at multiple points in time, and over some period of time and vantage points and checks and balances, reach a conclusion that this is actually rather stable. This is not a one-time spoof thingy. This is something that we can trust sufficiently because it's been around for long enough and it looks the same everywhere. And we could probably do something similar here. That said, that's about automatic bootstrapping. It's clear that in some cases you do want some sort of explicit confirmation that yes, this is indeed my key, me being a representative for the child. And of course we should have some sort of mechanism for that. On the other hand, if the child is just asked to please verify that this is your key, part of the problem here is that, well, if you ask a child, you have to confirm this, otherwise you cannot get further. They will just confirm. They will not know how to verify that it's their key. They will just sort of close their eyes and push yes. But if we could get it to something slightly simpler to confirm, like for instance, the IP address from which the update was sent, and we send the update only over TCP, then, well, most child operators would actually know what their source IP address is, etc. So I think we are at the point here where it's arguable that we could find a mechanism for bootstrapping the non-DNSX signed case by some suitable combination of, let's call them, by themselves not sufficient mechanism, but together a sufficiently stable state. We publish the key in the child zone, we send updates over TCP multiple times, we verify the source address, etc., etc. And whatever we get to will be vastly superior to what these people have today. Because we're talking about the corners of the internet where security is typically based on a phone call, a piece of paper, a fax, an unsigned email, etc. So we're not talking about the stuff that is getting worse by doing this. We're talking about stuff that is actually getting better by doing this. And if we get to a point where we can automatically keep the child-parent synchronization going by a sufficiently good bootstrapping mechanism, I think we've actually gained something. Questions? And then I'm good.
Yeah.
There you are.
Thank you.
Mark. Oh, no, there's a question.
There is a question.
Mark, please go ahead.
Bind already has TCP self for PTR records, the reverse zone, where we actually use TCP as the authenticator. So this is not new. I'm just letting other people know. It was put there so people could update their PTR records for themselves. A machine could update its own PTR record, or could actually do its own delegation in the reverse tree. Also, key can exist at the parent side of a zone cut, and named when it's doing SIG0 verification looks inside the zone for its self key stuff, or its child or subzone updates for glue. So it is definitely there. It's existing. There is existing code which shows how to do all this. So at the TOD level, I'd expect this to go through the EPP mechanism just to insert the SIG0 into a zone and have a name server just accept it after that. But the keys can be stored elsewhere other than in the zone. Okay.
I agree with all of this. Thank you, Mark.
Dan Gilmore.
Hi there. Thanks for this. Just noting in the chat that Ben Schwartz recommends that you replace over TCP with source IP verification, because there may be other ways to do source IP verification. I think like DNS cookies. I'm not sure if Ben wants to weigh in on that. I also want to observe that we are moving in the direction of allowing some sort of encrypted transport, which would not only have source verification, but would have some other kind of cryptographic controls. We don't have a clear understanding of what that means for authentication on the authoritative side at the moment, but you could imagine if the goal here is better than clear text, better than spoofed clear text packets, that maybe you'd be willing to accept just responses from a authenticated DNS over TLS or DNS over QUIC. That would give you probably more security than what you're describing here.
Thank you. I agree with that also. And just to let me clarify here that on this previous slide where I said we can do this and this and this in combination, I'm not trying to be descriptive that we should do it exactly this way. I'm just saying there are tools available that together will give us a sufficiently good bootstrapping mechanism for this, which really takes care of sort of the second issue with using dynamic updates for child-parent synchronization. The first issue being, where should you send them? And we deal with that in the generalized notification draft. And the second one is, how do you bootstrap it in the absence of DNSX signature chain? And this collection of mechanisms together, I think, will address that. Thank you.
Okay. Mark. Yeah, Mark was in the queue but disappeared. So Mark.
I dropped out.
Yeah. Okay.
I loaded.
Yeah. Okay. So I have one question from Ben, and one I want to ask one question or relay one question from the chat. So one question from the chat from Antoine Verschuren. This proposal would be a downgrade for child that know what they are doing. Could one opt out for this?
Well, anyone who doesn't want to do it shouldn't do it. There's no forcing mechanism here. It's just a new possibility that we're not using at the moment.
Okay. Thank you. And next question is from Ben.
Hi, that's Schwartz. I can't say I'm following all the details here, but I just want to ask: does this create the possibility of increasing use of DNSSEC by making it easier for children to get key material up into the parent?
I would say that this is orthogonal. It doesn't make it more difficult. It doesn't make it easier. This is essentially for parts of the namespace that for various reasons are unable or unwilling to do DNSSEC to still have automatic synchronization of delegation information. If you can do DNSSEC, I would suggest that you go with the generalized notifications and the CDS ceasing scanner path as well, probably a better alternative. But at the same time, we have 4% of the namespace signed and we have 96% unsigned. So there are a fair number of guys out in the unsigned part of the space that could use some automation.
Okay. Yeah, that's interesting, but it does seem a little scary. Like definitely it should be behind a big, pretty scary flag off by default on the parent side. Because this creates a persistent hijack mechanism. Somebody who's on path now can declare themselves to be on path forever.
True. I mean, there are enormous parts of the network. When we're not talking about the parts where there is a registrar, but parts where there is no registrar and it's just managed through ad hoc communication between the parent and the child. And that part of the namespace is not very secure today. And I'm arguing that it will not be less secure giving this. It would be more secure giving this because you can suddenly automate away all the human errors. But sure, it would be better if the entire namespace was DNSSEC signed. It isn't.
Okay, Mark next.
Benjamin, with these mechanisms, you can update all the delegation information. That can all be automated. But getting a trust anchor there getting a key that the parent accepts has always been the hard part. The rest has been doable for the last 20 years using update. There's really no reason a name server should not be updating the NS records. The primary zone should not be updating the parent, the delegation and the parent, or the glue records that it has been informed about and stuff like that. All this is completely automatable. The only thing that makes it hard is the fact that we've got the RRR system, which puts people in the middle, which aren't really needed.
So my real concern here is that if this makes it easier for children to sign their zones, then it's actually scary because it also makes it possible for an attacker who can break the security of this pretty weak check to step in and sign my zone with their keys. So maybe that's not true. I don't know. But if that is true, then that becomes
that's if you use this mechanism. That's if you use this mechanism to bootstrap it.
Right.
If you use if you use EPP,
gentlemen,
there's always trust mechanisms. What trust mechanism are you going to have? And we could put keys. We could use the existing mechanism to put keys in there, and then go completely. Once the key is there, do the rest of the automation. In the RRR world, use EPP to pass a the key to the registry and let it all work from there. And the same mechanisms can work all the way down the tree. Now the key doesn't have to be 60. 60 is just nice because you don't need to store clear text passwords. It's a nice mechanism using TSIG for security, but it's not the only mechanism that's available.
Yeah. Okay.
So
That's really useful, and thanks, guys. But I think that should continue to be thrashed out on the mailing list. And Johan, you have a final comment?
Oh, I get the final word. Thank you so much. Just to respond to Ben here about being scared about this, let me just point out that there's nothing automatic. Well, while we want to get to some automation, the automation is what happens after you have the key accepted by the parent and trusted. There's nothing that has to be automatic about that. These are just mechanisms to make it easier for the parent to accept the key. If the parent chooses a policy, and all parents have policies, obviously. If the parent chooses a policy that requires the child to come into the office and sign something in blood, well, that's fine. If the parent chooses not to require that, that's also fine. It's a question of the parent policy in the local case. And if we are somewhere, Swedish university, 200 departments, and they meet once a year, and they just sign off on this when they meet, we'll still gain a lot compared to what we have today. So it doesn't have to be dangerous, because that's a question of the parent policy. Thank you.
Thank you. And so the final presentations for Peter Thomason.
Everybody still awake? Okay. So a while back, I presented a draft that proposes when you process CDS records that you should check that they are consistent across name servers. So you don't act upon a CDS record and change delegation DS details when you haven't checked that all the name servers agree. And my impression was it would be useful to have done some numbers about how frequently those inconsistencies actually happen. It turns out I talked to people from Max Planck Institute in Germany this week, Tobias sitting in the back, and they had data about it, so we looked at the data. Next slide, please.
There's a clicker.
Oh, yeah. Next slide, Peter. Okay, so the data is about 300 million registered domain names, so like second level and third level with CO UK and that stuff. And they actually collected all kinds of data from all authoritative name servers of each delegation and also of the name server names that are given on the child side. So this is parent and child centric if you want. So some basic insights from the data set. The first question for me was how to classify when let's say out of 3 name servers, one is unreachable. Do you count that as inconsistent or as consistent? Now the draft says if stuff is unreachable, you should retry a few times and then eventually give up and just disregard that unresponsive name server. So that's the same as considering it consistent or potentially consistent. And so that's what I did for those numbers here. I assumed that timeouts don't indicate inconsistency.
Maybe, yeah. So just checking if I have the latest version also uploaded. So give me 1 minute. I can double check. Yeah. Just
I did check the link actually on the slides.
All right. Just to make sure you have. Okay. I will remove this one. Okay. Now I'm sure you have the latest version. Okay, sorry for the inconvenience, but this
No
is
problem.
the last version. Yep.
Okay. So timeouts are treated as consistent or not an indication of inconsistency, actually. So out of the 300 million domains, there were 8.4 million that had CDS records and 1.3 million that had CDNS key records. And if you consider only the inconsistent ones, so where you got responses from several name servers that didn't agree, ignoring the TTL, but including inconsistency from one name server answering with an empty response and another, for example, giving a CDS record. That's inconsistent, but different TTLs we didn't consider inconsistent. Then you find that about 0.1% of zones with CDS records have inconsistencies, and also about 0.1% of zones with CDNS key records have inconsistencies. And then there is some statistical variation, I would say, but roughly 1 in 1,000. So that's the first insight. Then here is a case study. We redacted some names. So here is the NS record set. Actually, it has 4 name servers: ns1.redacted name server operator 1 and ns1.redacted name server operator 2, and then also ns2 in each case. And if you query the ns1 operator people, you get CDS record with key tag 3714 and corresponding CDNS key if you query it. If you query the name server operator 2, you get CDS record with key tag 19170 and the corresponding key. Now, the interesting thing is that this is under .ch. .ch actually does CDS processing. And as far as I know, they do not check consistency in this case, except for authenticated DNSSEC bootstrapping, which I guess those name server operators don't implement. And so what can happen here, like the way they do it is they check for the CDS record, and then when it stays the same for a few days, it's called accept after delay, then they provision the DS record. So I think 3 days. So they do it daily. And if you happen to hit 3 nights in a row, a name server from the same of the 2 operators, when you do this resolution, then it will appear the same. So I think the chance of that are 1/4. Like the first time doesn't matter, and the other 2 are like 1/4. And then you will think that it's all consistent, and you are going to provision that record. So in this case, the first of the 2 operators won. And so here's the DNS with display, and that is obviously broken. So this is exactly what shouldn't happen, and it could be avoided if CDS processing would do that check that the draft is proposing. Then here's another case study under .com. .com doesn't do any CDS processing, so this is actually not an issue. I think the zone also doesn't really have DS records, but I found it pretty interesting that even though this is a very large DNS operator, the CDS records across their name servers disagree. So there is NSCloud B, a bunch of numbers, and NSCloud 1, a bunch of numbers. And it turns out that they actually have inconsistent CDS records. I don't know how that can happen. I don't know if Google does the signing themselves. I don't know if this is customer provided secondary service. And I'm not blaming Google. I'm just saying it happens in all kinds of corners. And .com doesn't do the processing, but if this was now registered with, I don't know, some registrar who does the processing, it would be better to do consistency checks. There's actually a bunch of other names that I looked at, all kinds of, like there's an Israeli ISP, which has the inconsistency type of problem, except that they are not securely delegated. But if .il did do the scanning, then there would be a problem, and so on and so forth. So yeah, all kinds of domain names. In fact, 90 to 95% of those inconsistencies are because one name server or one part of the name server set responds with an empty record set, and another part does respond with CDS records. So that could be, for example, multi-provider setups where one provider uses DNSSEC and the other doesn't. So that's inconsistent. And there were 400 cases where all the CDS record responses served by all name servers in the set for a given domain were all non-empty. So they all agreed that there should be DNSSEC. But in over half of those cases, roughly 250, those were actually dual hosted by Google Domains and Wix DNS, which both do DNSSEC. And so they didn't do a proper key exchange, for example. So it's not a true multi-signer setup. It's just like essentially 2 halves of DNSSEC. And the anomalies were quite interesting. Sometimes in the parent, there was the Google Domains name servers, and the child DNS record set did serve the Wix DNS name servers, or the other way around. And I don't know why that is, and I don't know if it's related perhaps to provider transfers or who knows what, but it's within the set of inconsistencies, it's a pretty common one. And it also happens with other provider combinations, like in the .ch case that we had earlier. Yeah, so luckily this doesn't often pose a problem, like in the .ch case, because usually those domains are not securely delegated, so nobody does actually do DNS checking. But if automation was done, then it surely would be better to do it in a safe way and apply these consistency checks. So the misconfigurations happen at large operators, at small operators, not very frequently, but across the board. A significant number of domains breaks, roughly 0.1%, if the acceptance checks aren't done. And yeah, so I think any automation method for DS provisioning should not tolerate that failure rate. That's pretty much it. I think probably one could extract more stuff from this. This was just from looking at it yesterday afternoon. Yeah.
Paul Hoffman, can you go back to the .ch case? And this one back. I'm sorry, one further where you had the data. So I'm asking a question. I don't know if people will be happy with this, but in this case, you've got two answers where you've got, CDS, two CDSs and two different CDSs that are very different. What would you say if you had, in the second case, one of the CDSs was the same and one was different? So the RR sets, are incompatible, but you had an overlap. What would you have proposed that they do for consistency? Throw out the one where it does not match, or give up?
So the draft says when the responses that you get, as long as they aren't empty when you get them, or as long as there's no timeout, and when you get them, they must be equal up to ordering and TTR. So if one part is missing, it is still inconsistent. So you shouldn't act on it.
Okay. Anybody else? All right.
Sorry. Thank you, Peter. So this concludes the DNSOP working group session. Well, I'd like to express my gratitude. Everybody's still here at the very end of the IETF, at the very last session of the IETF. Thank you for your... Yeah, there's a social, it's a goodbye social. So please walk over there and see you there. Can catch up with each other. I'd like to thank the speakers, the presenters of the drafts. I'd like to thank the working group for participating and giving useful feedback. And see you all in Vancouver in July.
Thanks, everyone.
Yeah. Excellent.